Good afternoon. My name is Anushka Sharma, and I'm here to welcome you back to the Cutting Edge stage on day one of CogX 2020. I'm really delighted to welcome you and introduce our next session. The Cutting Edge stage is here to tell you about tech that's coming up in the next 12 to 18 months, and it's technology that you can use to think about how you're going to be shaping your technical strategy over the next 5 to 10 years. I'm really delighted to be here as your host today, and I encourage you all to join the conversation online using our hashtag CogX 2020. And if you've ever wondered about technology and thinking about how to use AI as a smart co-worker, we're about to hear from Professor David Barber, who is the Professor of Machine Learning at University College London. I'm going to hand over to David now, who's going to be taking over the next session. Thank you.
Good afternoon, everybody. So, yes, my name is David Barber from University College London, and I'd like to chair this session about AI co-workers. Well, this may be something that you've not come across yet, but I think it's a kind of paradigm shift which is happening in industry, and we're likely to see big changes in this area over the next few years. So really, this is about a new approach in which people are able to interact with machines much more naturally, both in terms of training the systems and actually in using them in practice. So to help actually give you some sense of really what's going on currently in machine learning and perhaps what's good and what's bad about it, I'd like to tell you a little bit about a story about a guy called Ben who wants to build a better cat flap. Okay, so this guy Ben here is a very nice YouTube video, and Ben has a cat called Metric, and this cat is very cute, but it often comes home at night carrying prey. And Ben would love to be able to block the cat flap when Metric is carrying prey. So Ben's not an expert in machine learning, but he has an idea that he can use machine learning to block the cat from entering the house when it's got prey in his mouth. So what he does is he hooks up a camera to his door. There's a little window outside with a cat flap door, and the cat is pretty quick. It only takes 2 seconds to run up the ramp. So all the processing will be done on the camera. And actually the hard part, though, is to make the system so the cat will be blocked, is actually the vision recognition system, the machine learning, the AI component. How do you get the vision system, the camera, to recognize that the cat has got prey in its mouth? So what Ben does is he runs the system over a couple of months, and he collects 20,000 images of the cat on the ramp, sometimes carrying prey, sometimes not. And the key thing here is that Ben hand labels every one of these 20,000 odd images as cat on ramp, cat on the ramp, cat with prey, not with prey, etc. And this is the classical paradigm that people use in machine learning. You know, they've got some problem, and then they get the data all labeled, usually by hand. And then once they've got the labeled data, they'll use that to train an AI system. So one of the great tools then is that Ben can use some machine learning vision system with those 20,000 labeled examples, and then he can train the system and to detect whether or not the cat's got prey in its mouth. So this is pretty cool. This is really, I think, a great demonstration of the progress that we've made in machine learning, both in terms of the capabilities of these systems, but also in terms of the utility, how easy it is for a sort of a relative non-expert like Ben to actually get a cat recognition system up and trained. And then he tests the system in practice, and it works pretty well. A few hundred times the cat's innocent, there's no prey in its mouth, it's correctly let in, it's just locked out once unfairly. And with 5 times the cat actually has prey in its mouth, it's blocked 4 of those 5 times. So this is in some sense a very, very useful system. So in a way, this is kind of a good story, but it's a little bit of potentially highlights some of the problems, 2 main problems with AI right now. So one of them is about getting training data. So Ben, it was extremely difficult and time-consuming for Ben to actually label all of those 20,000 images. And this is the typical kind of problem that we have with deep learning. And in industry, you need a lot of labeled data to get your system to be trained quite well. So in this case, Ben actually did all this data labeling himself. It's often common in industry to outsource this data labeling to get people, often in the developing world, to label these images or data points more cheaply. But sometimes that's not possible. Maybe there are reasons around data privacy that you're not able to allow other people outside of your organization to see this data. And there are other issues with that as well. Sometimes it's not possible for non-experts to label the data. So maybe it's a medical image scan and you need a radiologist actually to tell you whether or not this is, say, some kind of lung cancer or not. It's not possible to get, say, Mechanical Turk sort of workers to actually do this labeling for you. So data labeling is expensive and it's very time consuming. It's the biggest bottleneck typically in the machine learning training process. Another thing which is a little bit clunky is that actually often people have much more information about the way that problems could be solved rather than just a binary yes/no answer. So for example, in Ben's case, he could have said, well, maybe the mouth area around the cat's face is a useful area to focus your attention on because that's likely to be where the prey is. So there's much more information that people have about the problem than this clunky approach to just saying yes, no, is the cat got prey in its mouth or not? How can you elicit more naturally the information that people have about a problem? So that's problem number one. Getting data is difficult and it's a huge bottleneck. The other problem or the issue is that the deployment of the AI systems currently is pretty clunky. So the typical paradigm is that you go out there, you collect the label training data set. It's usually very expensive and very difficult to get. Once you've got it, you train the system, and then once that's trained, you just deploy it, and that's it. You don't actually revisit that deployed system typically. So this is not good in situations in which the environment is changing. So for example, in Ben's situation, it might have been that maybe there's a different cat comes into view, also wanting to run at the cat flap, but it's never been seen before. And actually the system may not know what to do with that. And how do you, ideally you would like the system to be able to recognize that new situation and then recognize that it needs some new information from Ben in that case to actually help it to retrain. Similarly, in situations where, say, in your banking loan situation, there's no point maybe using data which is, say, for example, in a pre-COVID situation, because the post-COVID environment were very different to that. So how do you rapidly retrain systems to take advantage of the new situation? So what these things also need is when they're deployed, so if a cat comes up the cat flap, cat ramp, which actually is not recognized by the system, ideally the system would say, well, hang on, I don't know what's going on here. I've never seen the situation before. I'm not confident in my prediction, and actually alert the human to step in at that point and actually prevent the system making an error, but also provide a new training example that the system can use to improve its performance in the future. And finally, another situation which is quite problematic philosophically is that people feel a little bit bad that AI systems are replacing them in the workplace. Actually, a much softer and a much more gentle paradigm would be that the AI systems are really there to help them as like a smart coworker, to help them solve their problems and do their work more effectively and efficiently. And actually, the human is then allowed to do much more human-like tasks. So, is there a way forward in all of this? So one of the ways forward, and this is where some of the paradigm shift is occurring, is through what's called active learning and deployment. So what would happen in this particular setting is that Ben would have labeled only a few images of the cat. The system would then train, and if it has a certain confidence in its predictions, you can say, well, for the remaining images which have not yet been labeled by Ben, you might say, okay, this image that I'm very confident about, this is clearly a cat with no prey in its mouth. But this other image, I don't really know what's going on here. I'm not very confident. And Ben would be asked by the system to label that particular image only. Then the system would retrain, and this process would repeat, selecting example images that is not very confident in its prediction. And so Ben doesn't have to upfront label all 20,000 images. but there's an active process in which the machine interacts with Ben to understand what the machine actually is capable of doing at any one moment. And this is typically much more efficient in terms of data labeling. You can often get away with an order of magnitude less in terms of training data requirements, and that's very, very effective. And another thing which is very useful is what's called weak learning or weak supervision, in which Ben can provide examples which are more natural. For example, he might say, well, I don't need to provide just yes, no, this is a cat with prey in its mouth or not, but you need to focus, say, on the mouth region or other elements which are instructive for actually how to solve the problem. So how to interact more naturally in terms of providing training data. And it's also very, very important that when these systems are deployed, that they have confidence, they have a confidence in their prediction. So if they say, actually, I'm very confident about this particular case, then that's fine. But if there's a data point or in testing that the machine is not very confident about, that's when the human needs to step in. So this is a very much a sort of, if you like, call to arms for a more AI co-worker kind of approach, where the machine is much more interactive with the human in terms of its training and deployment. So to discuss this, I'm very happy to say we've got three great panelists here. We've got Emine Yilmaz from UCL and Amazon, who's an expert in machine learning and its deployment in industry as well. Challis from Reinfer, who Reinfer are doing active learning and natural language processing for large organizations, enterprises to help train systems more effectively. And Raza Habib from Humanloop, who have a platform for how to do data labeling more efficiently. So at this point, I'm hoping we can go over to the discussion. So thank you, folks. So if this is so great, all this this kind of idea of interaction, why are we not doing it already? What is the problem? So Emine, maybe I can start with you. What do you think is the reason people are not currently using this AI coworker idea?
Sure. So there has been some previous work related to active learning, not in terms of AI coworker, more from active learning point of view. I think this notion of AI coworker is relatively new compared to active learning. But there are various reasons why it's not common use at this point. I think one is I believe this idea of AI coworker is even more important than before. So before there wasn't as much focus on it as there is need right now. And I think right now it's about time to think about active learning and this idea of AI coworker slightly different than it was taught before. I think now it's much more important than ever before because right now one of the major problems is the need for data. Everything is getting more and more automated, but the methods we use are the type of methods that need a lot more data, like deep learning methods. And there has been several examples in the industry where people thought the method is not working very well, like in context of search engines, for example. For many years, people thought deep learning techniques don't work very well and compared to traditional methods. And then people noticed that the reason for that was actually the lack of data. And once enough data is available, these methods can work very well. So I think now people realize the importance of this lack of data and how it could actually put people back or put some of the models back. And at the same time, data has become a lot more valuable because with GDPR and data privacy, people are becoming more and more conscious about like the value of the data, and it's becoming more difficult to get access to some of this data. So I think these are kind of some of the reasons why we didn't make as much progress. And also, I think until recently, some of the models built for like AI coworkers, such as active learning models, they weren't really designed for the models that we use now. Like for deep learning, you need different type of active learning models designed for deep learning, and there aren't that many available. So we need really to design different way of this active learning or AI coworker. I also think that active learning, the way it's designed, needs to be changed. And it has to go more towards like a real AI coworker. I think the model in traditional active learning, the model could only say, okay, I'm uncertain about this example. Can you label it for me? But ideally, it should change now towards a system saying, I'm uncertain about this example because, like in image classification, for example, I can't detect the edges in this one, or I can't detect the nose of the cat, for example. So that the system can ask, okay, I'm having difficulty detecting the nose of the cat. Can you show me more labeled examples related to this? So that you can get examples that are more targeted, for example. So the way we have been thinking about AI needs to change. Active learning and AI coworker is slightly changing. And there is some progress already related to this. Like in this example, you need a model that can identify what it is not able to solve or detect, like when is it uncertain about the prediction, for which you need models like that can explain why it's not understanding or solving the problem at hand properly, and ask questions to humans directly in a more human-like manner, not like label this for me, but can you help me with this and which part of it? Just like when a baby learns or when a child learns from a human. I think we are getting there with like work on explainability and interpretability of models, AI, like intelligent assistants asking human-like questions and so on, but there is still more coming there.
Great, thanks, Emine. So let's move to Ed from Reinfer. So Ed, you've been working a while with Reinfer and using things like this. What's been your experience?
Yeah, so I mean, I think this need for active learning is so acute because I personally believe kind of the biggest bottleneck for kind of the promise of machine learning to be realized is the fact that kind of expertise, the people that have expertise about what kind of business problems need to be solved, what kind of properties you want this software to have, are not the people that can create machine learning models and do that whole development life cycle. So just like kind of Excel would have kind of democratized access to making like simple mathematical models, we need a kind of new paradigm of software which democratizes access to machine learning. And in a way, it should be much more powerful than kind of that kind of Excel world, right? Because everyone can say kind of if something's an example of X or example of Y, right? That's not a complex thing. Whereas writing formulas with if statements, I often get stuck in Excel sheets, right? And I spend a lot of my time in kind of computer science and maths, right? So I really think that the kind of the biggest problem we have to solve is how we can get this technology in the hands of experts. So that's business people that understand kind of the business problems they need to solve. And so, yeah, there's the problem around like how you architect these systems. And there's also, I think, a big problem around the kind of UX and UI that you put around this, right? So, I think in the kind of mathematical treatments of active learning, it's often phrased in kind of what's the minimum queries I ask the human. But actually, when a person's interacting with these systems, you want it to be really responsive. You don't want there to be like a 20-minute retraining cycle every time you give it a new piece of information, or God forbid, like a 10-hour kind of retraining cycle. So these things have to be like dynamic and fast, and then they have to kind of display themselves in a nice way. And all of those problems are kind of unsolved, right? We don't really know. There isn't a design language around this stuff yet. And there aren't kind of, in the back end, kind of accepted architectures for how you implement these things. So it's all kind of new territory, but it's absolutely necessary for us to solve these problems for machine learning to be truly useful.
Great, thanks, Ed. So Raza, you're relatively new in the startup, area here with Humanloop. But what's been your experience so far? I mean, what makes you excited about this as an area?
Yeah, absolutely. I have to say, I really agree with what Ed said, that there's an extent to which machine learning offers this amazing opportunity to scale expert knowledge and for a new paradigm of programming in which, instead of sort of, as Ed said, programming through if statements and things you would have done in Excel or in sort of as a software engineer, actually data becomes the core to this, and you move into a world in which you're almost teaching computers rather than programming them. And to your point of why this hasn't really happened so far, I think there's really two reasons. And one is, I think it's just appropriate tooling and knowledge. So building most of the software that exists around machine learning today doesn't make it easy to implement active learning. There's not good software systems that just allow you to deploy that very straightforwardly. And a lot of people actually don't have that good knowledge about this. In a recent survey, something like 36% of machine learning practitioners, and not even sort of non-experts, didn't know how to deploy these things themselves. And then the other reason is I think it's just a culture thing. Machine learning is almost still stuck in a kind of waterfall era of software design. Sort of you first collect your data, you then annotate it, you then hand it off to a different team of data scientists to do the modeling, and then you hand it off to a different team of people who actually deploy that model. And to make active learning work, to get something that looks more like an AI coworker, what you really need is the ability to actually combine all of these systems into one process. And that's the technology we're trying to build at Humanloop, the ability to annotate data with a human in the loop and deploy that so that even after you've deployed, these systems continue to improve and get new data.
That's great. So, I mean, in all of three of you, to some extent, you touched upon the idea a little bit. The paradigms are important, right? In the sense that if people don't know about this, then they're not going to use it, right? So that we seem to be kind of, as a field, a little bit sort of, not stuck, but we're a little bit, we're inculcated in our ways around this, as you say, or as this idea of, well, you've got your training data, you train the model, and then you deploy it, and that's kind of it, But maybe there's a point here that I think we need to sort of make people aware that actually that there are alternative approaches and paradigms available, and people need to actually to be aware of that. So I think I don't know, Ed, maybe you can talk a little bit about this, and when you're going around and you're trying to explain this to people in the industry, what's going on, what's been the reaction you've had in general?
Yeah, I think that's a great question. So I think there's the kind of like AI is almost it's in a kind of every newspaper, every kind of news show you listen to or watch. So everyone's aware of these kind of concepts and what the technology can do, maybe slightly overblown. But there is a kind of a real lag between the understanding of what it means to get these things into production, into a kind of commercial organization. And there is a bit of kind of education that is typically needed. If you meet a kind of a team that has tried to take a machine learning model to prod, then they're kind of aware of all of these issues, right? And then you come to them with an answer. But if you're talking to someone who's at the beginning of that journey, yeah, you need to actually explain it, that these things aren't as straightforward. You can't just buy a big GPU and hire some machine learning engineers and then hope to get something into production in a reasonable amount of time and have that, software maintainable and continuing to provide value. But there are a lot of other components you're kind of missing in that stack. So we definitely, there's a big kind of conversation to be had with a broad kind of section of the market. Those people that are ahead of these things and put them into production, they're kind of really cognizant of some of the pains that you will encounter in that process.
So Emine, you were saying, I think that some of the tools may be not really suited, well to, at least in the deep learning space. I mean, can you explain maybe a little bit more why that's the case? I mean, from a layperson's perspective, it seems, well, it's kind of the concept exists. And what makes it difficult to do this in deep learning?
So in deep learning, usually the models are machine learning models are quite deep in a sense, and it's difficult to infer like what are the effects of different components of the model to the final accuracy, for example, or detect why the uncertainty is caused by the model. And the type of like to reduce model uncertainty or to reduce the need for labels, you really need to develop methods that are suited for this particular case. And for deep learning, because of the complexity of the model, it becomes a little more complicated. There is some work, but very new, and I believe, like David has, you have done some work related to this, but it's very new. I'm not aware of too many related work that could be used to reduce annotation costs specific to deep learning, and now most of the models we use are based on deep learning, so it's a major challenge.
Yeah. So maybe go to Raza. I mean, where do you think the most likely benefit is going to be from using, let's imagine these tools are available eventually, and then where we're going to be using them. I mean, what's the sort of the low-hanging fruit, if you like, in terms of the best areas? Is it image recognition? Is it I don't know, natural language processing? Where are we likely to see these systems used?
Yeah, what we've been seeing is sort of as an initial use case, the places where people can get value very quickly are actually places where you have expert knowledge. So we've been seeing things in the legal space, and also potentially in the medical space, where you would have potentially doctors needing to understand medical notes or contract review. And these things have been fairly primitive in the past. So there are tools for e-discovery, or there have been tools like Raven or Luminance that allow you to understand contracts more quickly, but they're not as interactive as you might like, and they don't let you then make decisions on top of that information. And so being able to understand these documents very rapidly in a way that's interactive is probably one of the first places where I think this will make a huge difference. And in the last few years, there's been a real step change due to models like transformers and sort of these large language models in what NLP can do. And so we're probably for the first time ever getting to the stage where almost any large company will be able to benefit from natural language understanding.
So, I mean, do you think, and this is a question perhaps for all of you, that, you know, people talk about automation and, you know, it's happening at pace in some areas and lesser in others. But I mean, is this likely to accelerate? Or, for example, you know, is COVID an example where we're likely to see an acceleration of the use of these kinds of technologies as people realize that actually, you know, maybe these kind of, you know, for example, if the systems change, you know, the data, the whole setting and the environment has changed, like in that banking example, well, where, you know, actually if you're thinking about giving loans, where the training data is perhaps no longer so relevant as it used to be. Is this a kind of area where we're likely to see more activity with things like AI co-workers and active learning come into play, because they actually will help more rapidly retrain systems? Is that likely to be a driver behind adoption of these kinds of technologies?
So I think you know, one of the things you have to like think about with most kind of large enterprise businesses which we deal with, right, is there are kind of a number of forces at play which are kind of preventing them from really accessing machine learning and AI, and often that's a kind of slightly behind the curve with the adoption of cloud technologies. So a lot of them are still running a lot of software on premises on their own machines, and that hardware tends to be quite outdated, and it typically doesn't have GPUs, which are absolutely essential for kind of running any kind of modern machine learning stack. And so things like the only reason, you know, obviously this is COVID is a huge impact on the economy, but the only reason kind of all the white collar sector can continue is because of cloud technologies, right? And so COVID is actually a huge accelerant for kind of enterprise businesses' digital transformation, so moving things to more digital kind of online tools and technologies. So that's a huge forcing function. And I do think that things like COVID accelerate, like underscore like how much businesses need like agility, like how much they can change the property of a software system, like and how long that takes. And without something like active learning, you just can't do that. And you know, when I became aware of COVID, you know, I started to call up all our customers and just see how they were doing. And a lot of them already used Infer to create kind of models bespoke to COVID, because they have international operations and they have teams in China and Southeast Asia, and they were already using the tool to understand and monitor and automate that stuff. So you absolutely need to, agility is so important with software and flexibility. And I think any kind of shock just underscores that, you know.
Yeah, so maybe I can switch to a slightly more philosophical point now, which is that this all sounds great, you know, the idea of systems which are interacting with people and helping them. But I could also sense maybe there's some unease about that, you know, is how do people feel about a system which is potentially, you know, now interacting with them? Is that going to be a little bit problematic in some sort of ethical sense? Are people going to be more nervous about, well, the machine's asking me, you know, more and more about my own personal abilities and my feelings about, you know, this particular problem? That seems to be, you know, is that a potential clash there? I mean, are people likely to feel comfortable with this kind of more interactive AI machine approach, or is it something that is likely to be, well, that's not, we don't want to go there. It's not really appropriate. Emine, maybe you have some experience around that a little bit.
Sure. I think we have to be careful that users do feel comfortable about working with AI. Like, for example, in some cases, when the users feel that AI is monitoring them, that is indeed a potentially uncomfortable feeling. But AI doesn't necessarily need to monitor all the activities of the user. They only need certain aspects that are related to the particular task AI is kind of trying to help the human with. So that's why privacy, differential privacy, and so on, techniques like this are becoming more important. Also, in many cases, it's not that particular individual that the AI is looking for. It's more aggregate over behavior of many individuals, aggregate behavior across them that the AI needs. So it's not like an information about particular individual. I think we have to make sure that people are aware that they are not really monitored, and we have to be careful when we design AI, so that the techniques that are used are designed in such a way. And that's why I think this intelligent coworker and active learning and so on, it comes hand in hand with work on privacy and differential privacy. So in the next few years, we definitely need more advancement in these fields as well.
So Raza, go ahead.
Let me add to that, David, as well. One of the things that I'm really personally excited about this new paradigm is not that we should watch people and monitor what they do and sort of try and replace it, but actually that by giving people the ability to program computers by example, by teaching, you actually allow people to have a lot more control over what the AI and software can do than was maybe previously possible in these black box deployments. And there used to be this metaphor that one day computers would be like bicycles for the mind, something that would augment our abilities rather than replace them. And I feel the active learning paradigm, this ability of like teaching the computer to help you, actually offers that possibility. So it's not a question of being monitored. It's a question of working collaboratively with the system.
Yeah, I totally agree. But also, there were people whose job it was to do, simple kind of arithmetic and calculations. I think, people actually had like the job title to be a calculator or something, so
computers that.
Yeah, exactly. So these things will change the nature of work and will change the roles that people have, but I believe they will give people kind of superpowers to do more. But so I think on the micro scale, everyone likes having good tools and being enabled. On a macro scale, I think societies have a responsibility to think about the changes to the job market and how to kind of give people the safety net that's necessary. I mean, these things will create, I think, a huge change to our society and the way that people work. So there's definitely not kind of naive questions. I think it's really important that societies start to think about how we're going to deal with this new technology.
So also, in some sense, I can see very positive aspects of this, in the sense that there are you can free up people to do more human-like tasks, which is great. But also, it seems like maybe on the negative side, is that, well, actually, that organization which is now potentially using the I helped train the software tool through my expertise in that organization. I've told it the answers and in certain cases, and I've actually told it how to solve certain tasks. So to some extent, it's good because you can now, if you like, scale up across your organization the expertise of an individual, which sounds great. But what happens when that individual leaves the organization? Are they now, do they feel that they've left some of their own intellectual property, if you like, behind the organization, or are they going to feel bad about that? How's that going to pan out in the future?
Well, I would do a couple of things to that, right? Firstly, I don't think that you're ever going to be able to capture the entirety of an expert's knowledge. So the things that we're teaching the computers to do are really a small piece of what that person does. But also, I would say just look at the alternative, right? Which is that you have a small number of really key employees who, if they leave, they take years of knowledge and experience with them. And actually, this is a chance for them to leave something behind for the rest of their team to continue benefiting from their work, not just when they're there every second, but even when they're not available. As you said, to scale them across an organization.
Ed.
I mean, David, Emine, you're professors, right? I mean, you've dedicated your life to self-replicating your knowledge and expertise, you know. So, I mean, I think machine learning is still in this kind of age of kind of interpolation. So, you know, we can kind of teach machines to do these kind of tasks, but they're a long way off from solving the more complex things that most employees are engaged with at work, right? So this is really it's really about kind of scaling an expertise and making experts more powerful and productive rather than replacing. We're some way off from replacing.
I believe there are two types of work that an employee does. One is this repetitive tasks that are probably going to be replaced with AI, and the other part is this more creative task that definitely require human input. And when we have AI systems as a coworker, these repetitive tasks, the AI system will stay. It's like the expertise, even if the human leaves, the expertise of that, it stays. It's the more creative part that might leave, like the expertise related to that when an employee leaves. But then it's really the core part that needs to be transferred to the next employee, for example. So I think it might be even helpful in like this like employees moving around in terms of knowledge transfer, because the repetitive part stays with AI and AI stays with the company.
Well, this sounds all very kind of, you know, futuristic almost. I mean, where are we really? I mean, do we have anything like these kind of tools right now? I mean, are we talking about 5 years, 10 years from now that, you know, we're really going to be able to have tools that we can, you know, very, very comfortably interact with, or is that much more? Is the horizon much shorter before we're going to get all of these things?
I think the horizon's much shorter. I mean, I would say that, you know, Reinfer has all of the properties of these kind of systems that you're describing, and we're going to see these same kind of patterns of interaction with these intelligent coworkers emerge for different business problems, different, you know, kind of types of data. This stuff is very, you know, it's new, and it's being kind of developed by loads of different companies and loads of different sectors. But it's still very new, you know. I think it's just working its way out through the market.
There are some particularly innovative companies like Reinfer that already have this in the market. The largest sort of tech giants have been doing things like this for a while. I mean, what we're trying to do at Humanloop is give the tools to most companies to be able to start building those things and have systems like that themselves. But it'll take time for that to percolate across. But the most tech-forward people already have this.
Yep.
So why don't we see it? I mean, you know, why are they not deploying that right?
I mean, if you work at Facebook or Amazon or Google or you know, you'll probably Facebook probably has 30,000 people. I'm just made the number up, right? But people doing moderation with active learning AI systems. I would imagine Amazon has the same thing in product categorization. Google has the same thing across content moderation and hundreds of other kind of applications. So these tech giants internally will have this tooling, right? It might not be a very nice, you know, it might not be very aesthetic. Maybe it is, but all of the tech giants have been working on this stuff for years, and what we're starting to see is that being made available and sold and commercialized and packaged up.
Yeah, although I would say, Ed, my experience, at least sort of having worked in some of those places, is they have it in a kind of patchy way. So it's not like this is done.
Productized, yeah.
And I think part of the reason for that is kind of what we said before about there's a kind of culture shift, right? Often the people responsible for data collection and annotation are separated from the people who are doing the model building. They're not necessarily the same teams, and there's often handoffs. And making active learning systems work in that kind of cultural environment can be quite tricky. I think you need tools that sort of reduce the barriers for this before it will be widely adopted. But the technology definitely exists. It's a question of productizing it and bringing it to market.
Yeah, I mean, some of the mathematical sort of, like, I think Emine was touching on this as well, that it's not so straightforward to do some of this. There are tools which are available, but getting good uncertainty estimates out of these deep learning systems is not so straightforward. The better the estimate of uncertainty is, then the more useful it is. I mean, it's a little bit like you can imagine if you had a real person as a co-worker and they were very confident, all the time in their predictions, but they were maybe a little bit arrogant in their predictions. And, sometimes they get it right, but sometimes they're very confident. Oh, they say, believe me, this is
They just get promoted, David. They just go straight to the top.
Maybe, but I think people are very sensitive to errors when people are very arrogant, right? They, well, this is definitely the right thing to do, and if they get it wrong, right? Then people are very, very sensitive to co-workers who are arrogant and not aware of their own limitations. And I think that's a similar issue a little bit with these deep learning systems. They're so complicated. Actually, as Emine was alluding to, actually trying to understand, the uncertainties that these systems actually have in their performances and their predictions is not so straightforward.
Yeah.
But I think there are, in my experience, tools which are coming on stream from the research community, I think, which we're seeing which can help in these situations and certainly come up with reasonable estimates of uncertainty in these deep learning systems. And I think whilst conceptually this is not necessarily new, computationally it's still quite fresh. And I think, as we were saying before, it takes a while for these kinds of tools to percolate from the academic environment through to the actual tooling that you might see in industry. And I think that's I'm hoping that will happen in the next year or two. So maybe just to in 30 seconds, starting from Emine, would you just like to sum up any take-home thoughts that people should have?
I think it's the time that, as you mentioned, some of these models, I think the need for like AI coworker, active learning, more embedded into the type of models we use is obvious, and there will be breakthroughs or more work related to that. I think the way we see AI as a coworker will also probably change, though. For example, in this example, like cat predictor, wouldn't it be cool if AI itself kind of predicted or noticed that Ben needed a bad cat predictor, and then looked at Ben's behavior, and AI learned how to build a cat predictor itself. I think that's the direction we are headed towards. Instead of us specifically training AI for certain tasks, AI learning from us, and then not needing as much feedback or labels from the humans. So the interaction becomes more and more natural. And so that would be kind of more like going towards this AI as a coworker and more natural interaction between humans and AI. And I think that's what's coming up in the next few years. And companies like infer and Humanloop, I believe they are headed in that direction. So there is work related to that in the industry as well.
Great. Ed?
Yeah, I think to any kind of business people out there thinking about employing this technology, I think you need to think about these things, right? So ask questions of any kind of technology or proposition. How long does it take to train? How do I update the model if I want to kind of correct it or add some new kind of feature to it? How do I maintain it? How do my kind of experts interact with it? That kind of whole the life cycle of a model and how it's controlled is so important if you're going to kind of realize the business benefits, and you need to have those kind of intelligent conversations to kind of realize them.
Great, thanks. Raza?
Yeah, I would say that, again, if I was a business person or someone who's not a machine learning expert thinking about using these technologies, what I would say is don't think about machine learning as just another tool in the software arsenal, because it really is something that's quite different. It represents a different way of programming computers, where really the data you use becomes the core. If I gave you the source code to the Google translation system, it wouldn't help you. It's the data that really matters. And so having a new suite of tools, the right tooling for getting the data, annotating it, curating it, building and deploying models in such a way that they continue to improve and you can understand that data over time, is really a different way of approaching things. And so sort of making sure you take a data first mindset is what I'd sort of take away.
Great. Well, then thanks everybody. It was a great session. Raza, Emine, and Ed. And yeah, see you next time. Bye.
Thanks.
Thank you.
Gosh, thank you so much. Thank you, David, to Emine, Raza, Edward, and David Barber there from UCL. Thank you so much. We have learned so much about AI as a smart co-worker. I don't know about you, but as someone who is an expert in a limited field, I think understanding the cognitive pressures and taking that off so I might be able to focus on a different area of the work I do in the creative way. This is a really interesting proposition. And remember, if you have any questions for David and the team, you can link through on Slido. There is a Q&A session, which is going to be kicking off at 1 o'clock for half an hour. And so if you have the right ticket there, you'll be able to proceed through to the Q&A session. This is the cutting edge stage. This is day one of CogX 2020. My name is Anushka. I'm your host, taking you through all of our proceedings today. We'll be back at 2 p.m. on our next subject, which is exploring the interplay between artificial intelligence and collective intelligence. I hope you'll join me for the next session. Make sure that you're joining the conversation, using the app, networking with your fellow virtual attendees, and join the conversation using hashtag CogX 2020. I'm Anushka. I'll be back at 2 p.m. to welcome you here on the Cutting Edge stage. Thank you.
Want access to more CogX videos? Subscribe now for free at cogx.co.